All right, so we're looking at the Unit 8, the first day, which is right triangle trigonometry. Your homework tonight will be the Day 1 worksheet. And today we're looking at trigonometric ratios and the basic rules of trig. So let's get started. So trigonometric ratios have to do with right triangles for now. You will be able to use them in other triangles, but we're starting with just right triangles. So for this unit, it's all right triangle trig. So the first thing you need to know is the opposite, adjacent, and hypotenuse of a right triangle. So the hypotenuse is pretty straightforward. You've done that before. It's the longest side. It's across from the right angle. So if you turn this into an arrow, it will point at the hypotenuse. The legs can be labeled as opposite or adjacent, and that changes depending on what angle you're looking at. So if you're examining angle X here, we're dealing with this one that's got the little mark in it. Opposite it will go across the triangle to the opposite side. So opposite is over here, O. Again, it's across the triangle from the angle you're looking at. The adjacent angle, or the adjacent side, is right next to the angle. It actually makes up the angle. So adjacent, down here, A, is right next to angle X. So opposite is across from, on the opposite side. Adjacent is right next to, making up the angle. And the hypotenuse, again, always the longest side across from the right angle. So the first thing I want you to do, it seems really simple and elementary, but I want you to label opposite, adjacent, and hypotenuse for each of these triangles. We'll do the first one together. So this first one, we're looking at the angle that has the little arc on it here, so the one that is marked. And that's true for all of them. You're looking at the one that is marked on each triangle here. So looking at our first triangle, here's our arc. I like to find the hypotenuse first because it's really straightforward. I have my 90-degree angle, go across from that, and there is my hypotenuse. So I label it with an H. Then I like to look at my opposite. So I have my angle here. I go opposite from that, and that is where I label my O. And that means that the last side that's left has to be the adjacent side, or A. So pause the video, take a second, and work through each of these, labeling opposite, adjacent, and hypotenuse on each triangle. All right, so I'm going to go through these kind of quickly just because it's pretty straightforward. So we're going to start with the hypotenuse. We're going to go across the triangle for our opposite, and then have our adjacent. Same for the next one, hypotenuse, across for opposite, and adjacent, hypotenuse, opposite, adjacent, hypotenuse, opposite, and adjacent. Now we're going to throw some numbers in there. So the first thing you want to do here, the first question says the hypotenuse is going to be how long? So if you know that this is a right triangle, that means you can use something called the Pythagorean theorem, which is a squared plus b squared equals c squared. So in this case, 3 squared plus 4 squared equals c squared. And when you solve that down, you'll end up with a c value of 5. So our hypotenuse is going to be 5 units long. The next thing you want to do is find the side opposite from theta. So we're going to take our theta, which is right here, our theta, and we're going to go across the triangle from that. So our theta value, and again, this little symbol here is theta. Our theta is going to be 3. The side opposite theta is 3. Beta, B-E-T-A, is this value right here. That's what this symbol is, beta. And we want to go opposite that. So across from beta will be 4. Again, our adjacents, so adjacent to theta, right next to it is 4. And adjacent to beta is going to be 3. So for both of these, so these values down here, theta and beta, are just two variables. So when you're dealing with angles, they will use theta now instead of using x or y. And then a lot of times they'll use beta also if they need a second one instead of going to letters. Letters typically represent lengths. These are Greek letters, which typically represent angle measures. So that leads us to this down here. What is the value of theta plus beta? Well, we know that a triangle has 180 degrees. We know that there's 90 taken out right here. So that means that the last two put together have to also equal 90. So let's get a little more complicated than that and talk about some basic trigonometry rules. So there are 6 trig functions: sine, cosine, tangent, secant, cosecant, and cotangent. We are going to talk about the basic trig, which is just sine, cosine, and tangent right now. So these are ratios, which means they're going to equal fractions. So sine is going to equal, so we have our opposite, adjacent, and hypotenuse. And sine of an angle is going to be the opposite over the hypotenuse, or O over A, over H. Cosine is adjacent over hypotenuse, or A over H. And tangent is opposite over adjacent, or O over A. Now, if you have not heard this before, you can use this acronym to remember sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So, ka, toa. That's just a way to remember it. If you have another way, that's perfectly fine too. Please remember that these only work in right triangles and that the hypotenuse is always across from the right angle. So going in a little more depth, we want to write each ratio as a fraction. We're not going to write them as decimals because that's just plugging the fraction into your calculator for now. So sine of A, well, we need to know that sine is opposite over hypotenuse. And we're looking at angle A right here. So using angle A, we need to find the opposite, which is going to be 8. And the hypotenuse of this triangle is 10. So sine of A will be 8 over 10. The second one here, cosine of B, is now looking at angle B. And we know that cosine is adjacent over hypotenuse. So cosine of B is going to be the adjacent side, which is 8, over the hypotenuse, which is still 10. So 8 over 10 will be your cosine of B. And tangent of A, going back up to the top here, is going to be opposite over adjacent. So from A, we go opposite, which is 8. And from A, our adjacent is 6. So 8 over 6. What I'd like you to do next is pause the video and try and find tangent of B, cosine of A, and sine of B. So the tangent of B is going to be opposite over adjacent. So from B, we want to go opposite, which is 6. And from B, our adjacent is 8. So 6 over 8. Cosine of A is adjacent over hypotenuse. So our adjacent to A is 6, and the hypotenuse is still 10. And sine of B, so sine is opposite over hypotenuse. So we're going to go opposite to 6, and the hypotenuse is still 10. Number 2 gets a little more in depth even than those ones. So it says, given cosine of beta is 11 over 17, find sine of beta and tangent of beta. So as someone said earlier in the day, when in doubt, draw it out. So we know that we are dealing with right triangles. So I'm going to draw a right triangle and label one of the angles beta. Well, we know that cosine is adjacent over hypotenuse. And in this case, cosine is 11 over 17. That means that our adjacent side is going to be 11 and our hypotenuse is going to be 17. So from beta, we can say, okay, our hypotenuse is 17. Our opposite side's over here, we don't know that. And our adjacent side is down here, and that is 11. Now to find sine and tangent, we need to know that O value. So we have to use the Pythagorean theorem. So O squared plus 11 squared equals 17 squared. And when you solve that down, you will get the square root of 168, which is not okay anymore because we know how to simplify radicals. So that'll be radical 4 radical 42, which is 2 square root of 42. So our O value over here now is 2 radical 42. And now to find sine of beta, sine is opposite over hypotenuse, so 2 radical 42 over 17. And tangent of beta is going to be opposite over adjacent, which is 2 radical 42 over 11. So our two answers will be this and this, which do not look very nice, but they are the answers. This next part is super straightforward. It says use a calculator to find the following. The only thing you have to pay attention to is that this says degrees, 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 degrees. Make sure your calculator is in degree mode. Make sure your calculator is in degree mode. You do this by pushing the mode button on your calculator, which is next to the second button, and going down 2 or 3, depending on which calculator, and making sure that degree is highlighted. We want to be in degree mode. And then you just put into your calculator, sine 13, close your parentheses, hit enter, and it'll give you a really long decimal. And in this case, we are rounding to the nearest tenth. So it will be 0.2. Pause the video, please, and complete the next 3, rounding to the appropriate decimal place. Okay, so cosine of 46 degrees will give you 0.695 when rounded to the nearest thousandth. Tan 64 is 2.0503 when rounded to the nearest 10,000th. And 15 cosine of 45 is 15.61 when you round it to the nearest hundredth. We're going to do the next problem together, but I'm going to want you to skip number 8 when you are working on your own. So number 5 here says 21 times the tangent of 45. You're going to just put in your calculator 21 tangent of 45, and it will give you 21. And then for number 6, it says what is the value of cosine 68 to the nearest tenth? So you will round that to the nearest tenth from your calculator and get 0.4. Number 7, a little trickier. So the first thing we want to do, if we want to find x for this one, is figure out which of the trig functions we're using. So I'm going to go through and label each of my sides, my opposite, my hypotenuse, and my adjacent. And I'm going to notice here that I have a hypotenuse, and I'm looking for the adjacent side. So the the trig function that uses adjacent and hypotenuse is going to be cosine. So if I plug in everything that I know, I'm going to have my adjacent is x, my hypotenuse is 21, and then I'm going to do cosine of 16 degrees because that's the angle that I'm working with right now. So from here, if I had written this as cosine 16 over 1, I could go ahead and cross multiply that and get x equals 21 times the cosine of 16. And when I plug that in my calculator and round it to the nearest hundredth, I end up with 20.19. I would like you to pause the video now, and I want you to try numbers 9, 10, 11, and 12 on your own. Okay, so number 9 is similar to number 7. The only difference is when you set up your ratio here, your trig ratio, your x is going to be on the bottom, which changes things just a little bit. So again, I want to look and see which sides I'm dealing with, and in this case, it's going to be hypotenuse and opposite, meaning that the trig function we're using is going to be sine. So I'm going to plug in 8 for my opposite, x for my hypotenuse, and I'm going to have sine of 45 here. Now, when I cross multiply, I'm going to do x times sine of 45 equals 8. And now I could plug sine 45 into my calculator and get a really long decimal. And if you want to do that, that makes you more comfortable, you can. You just have to write out a really long decimal and then divide by it. Otherwise, you can just divide by the sine of 45 and put this whole piece into your calculator. 8 divided by sine 45, and then round it to the nearest tenth to get 11.3. So again, similar to number 7, but a little bit trickier. The next couple here, number 10, you will get x equals 21. Number 11, you will get Choice 4, 112.